All right, in this problem, we have a 20-pound block that's sliding down a 30-degree inclined plane, has an initial velocity of 2 feet per second. We want to find the velocity after 3 seconds if the coefficient of friction is given that. Now, we could use Newton's second law acceleration, but because this is an impulse momentum sort of problem, we're going to set it up that way. So we'll start looking at a free body diagram. So again, I've got gravity, I've got a normal force, and I've got a friction force. Okay, and this is sliding down the incline, going down and to the left. Okay, so I'm going to set up my axes along the direction of travel in the incline. Okay, so I'm going to sum the forces essentially in the y direction first. Well, not the forces, excuse me. I'm going to apply impulse momentum in the y direction first. So I'll have my initial momentum plus the impulses equals the final momentum in the y direction as I have here. Now the thing is I have no velocity in that y direction. It's moving completely in the x direction. So my initial and final momentums equal 0. Okay, my impulses are my normal force and then my weight cosine of 30, and these are both constant forces. The normal force and gravity are both constant. Okay, so I just take those times the 3 seconds, right? It's force times the time duration. Okay, so I have n times 3 and then 20 cosine 30 times 3. Solving for n, I find the normal force equal to 17.32 pounds. Doing the same thing in the x direction down the incline. Okay, I have an initial momentum plus my impulses equals my final momentum. Now this time my initial momentum is 2 feet per second, excuse me. My mass is 20 pounds divided by 32.2. Okay, so that's my initial momentum in the going down the incline. Then I have gravity helping me in the same direction. That's the sine 30. It's 20 sine 30. Again, that occurs over 3 seconds. That's my first impulse. My second impulse is the friction, which is opposing it, so it's negative. It's acting in the opposite direction. And that's the kinetic friction times the normal force, so that's 0.25 times 17.32 times the time duration, which is 3 seconds. That equals my final momentum, which is, again, the mass, which is 20 divided by 32.2 times the final velocity, which is what I'm looking for. So again, initial momentum plus my impulses, I have 2 of them here, gravity and friction, equals my final momentum. Very simply, I solve for v, and I find that it equals 29.4 feet per second. So again, you can use impulse momentum in several directions. It's a vector notation in order to solve problems that deal with force, velocity, and time.